Hey everyone, and welcome back to the Information Bottleneck. And today we are going to talk about evaluation and how can we actually, how should we evaluate our models. And for that, we brought Florian Brand. He's a research engineer at Prime Intellect. So hi, Florian, how are you?
Hi. Yeah, thanks for having me, Ravid and Alan.
And hey, Helen, how are you?
I'm doing good. It's great to have another person who can talk with us about evals on, because it's probably the most important topic in all of machine learning.
So I think we can start from the beginning, like maybe the most fundamental question about eval. What we actually want to measure?
That's a great question. Evaluations are mostly used as a proxy for something we care about. So they don't try to replicate like every setup and everything that a user wants or might be able to do, but it tries to build something that is close enough to the real world, and also that is an important part of evaluations versus the real world. It tries to make that somewhat reproducible and somewhat in a controlled way. And over time, the things we cared about have changed a lot. If we think way back into 2020 or 2019, like the initial language model days, we have had benchmarks that mostly looked into the pre-training stage of a model training. So we had things like MMLU, which just tested different knowledge questions, some of them really weird, and also a lot of them which were based on the time. So a lot of, if you actually look into MMLU, a lot of them have the cutoff date of the questions, so 2019 in them. And we mostly wanted to measure how well the models were able to learn the huge knowledge they got, which is completely different from how we evaluate LLMs right now. But like that was the thing we cared about first. And then we used the models more and more, and they were able to saturate this knowledge benchmarks. So we tried to go into the reasoning direction, and tried to push the models into combining knowledge based on its pre-training knowledge to then answer new questions with things like GPQA, which is a benchmark to test reasoning with regards to biology, chemistry, and physics. And the goal for that was to test whether models are able to answer really hard questions on the level of a PhD student. And once the models were somewhat able to answer these questions, we were like, all right, let's try to see how well they are doing at coding with things like SweBench. And nowadays we push them even further, and we care about things like law or accounting and so on. So benchmarks continuously evolve, both with the capabilities of the models as well as our expectations on the capabilities or on the products we use them in.
And how? So first of all, like, what are the current paradigm? Like, how current benchmarks look like?
So now we are basically all into the agentic phase. We don't really care about knowledge anymore. And in fact, if
Why?
you look at
Because we think it's a solved problem?
that, and also, or mostly because all models these days are kind of agentic, and we gave them tools, and one of the tools is, and that's built into every product these days, and one of these tools is a web search tool. So we just said, all right, the pre-training knowledge is not that important anymore if it can look up the facts in the open web. And that's why you see the models actually regressing on some of the knowledge benchmarks over time. With the most significant example, or the most modern example that is still used, is a benchmark called Simple QA, which has like harder knowledge questions with more niche knowledge. And the models first or almost saturated it. And then as the time went on, models got actually worse because it was not a focus anymore, because everyone was saying, all right, we are doing web search, and for that you don't need that vast pre-training knowledge.
But
and
is
these,
it?
oh, sorry.
Wait, I just want to focus on this thing, because like at the end, do you think this is because like people like stop overfitting this data set, or like we have some like general approach that like we don't care about knowledge and specific details?
I think it is mostly a switch of focus here. That doesn't mean that the models should not have any knowledge at all. And in fact, if you use the models these days, for example, for experiments in machine learning, you see their pre-training knowledge being a dominant factor for the kind of experiments they run. So a lot of them, if you do language model experiments, want to do LoRa, want to do PEFT, and don't know all the new interesting things. And are hesitant to use things like reinforcement learning with all the latest advancements. So pre-training knowledge is something that you should not neglect, but in general, we have moved on from the models being a sponge of all the knowledge we have.
Wait, are you claiming that across the industry?
I would say mostly, yeah. I think the Gemini models are really good still at those knowledge-based questions, at least if you look at the benchmarks. But in general, the focus is definitely going towards reasoning benchmarks, towards agentic benchmarks, and that means knowledge is less important as the knowledge can be looked at.
Well, so we know there's several papers that show that all of the instruction fine-tuning phases reduce diversity of model outputs. And I'll point out that one of the least slopped models that ever came out was the original Kimi K2. And my understanding is that it had reinforcement learning with AI feedback, but with no human feedback, like kind of on purpose for this reason. So do you think that we'll be able to get around these kind of diversity trade-offs in the future?
I think it is mostly that the labs want to go into one direction. And because you mentioned Kimi was like one of, and especially Kimi K2 was one of the most interesting models and one of the most beloved models by the community for its writing style. And that's the one thing you remember about Kimi, because all the subsequent releases focused so much on coding that this kind of diversity got lost, because everyone realized, hey, coding is where the money is, where everyone is focusing on. So let's go into this direction and let's put less focus on things like creative writing, which is kind of sad if we are being honest, but that's where everyone seems to move towards.
Okay, so how we actually measure today? Like, what you think are like the current good benchmarks today? Like, what types of capabilities they actually measure?
So the current type of benchmarks is almost exclusively agentic benchmarks. With a lot of focus on coding. And for coding, because it's kind of weird, because the models are so good these days, that we have to find new and new angles that are somewhat novel without the benchmark being too weird or stacking too many things on top of each other, that we are focusing more and more towards long horizon benchmarks, which means that you have a single task which does not need like 10 or 15 minutes or even 30 minutes to solve, but hours or even days. So we are now in areas where we kick off a prompt, and which is also what you are seeing right now. People kick off a prompt, define a goal, and then go away and let the model run for hours or days or even weeks these days to try to accomplish some goal. And that's where a lot of focus is right now. And the other area, like coding, is almost saturated in a lot of ways. So we are now looking more, or the general community is looking more into other white collar work, with things like accounting, with things like consulting, being good at using and creating Excel sheets, being able to create good looking PowerPoints, because more and more people are using these things and more known coders are using these things, and things like Cloud Co-work, that we realized, all right, that's something we need to capture in benchmarks. And the next area that we are seeing right now that will crop up even more in the next half year or so is life science. So all biology and chemistry related things will get even more focus in the coming months or in the coming year.
And how do you think is the right way to measure it? Like how these benchmarks actually look like? You validate the results, or like can you give us like examples of like the type of question, the type of answers, how we collect them, and how we measure it?
Yeah. So for I think a lot of long horizon coding tasks is like one big area where we have one library or one binary or one program where we tell the model, all right, this is a thing I have. Some of them show the source code, some don't. And I want you to basically rebuild this thing in another programming language. So this is the initial prompt. And then the model is tasked to replicate this. Sometimes it has access to some test cases, sometimes it has not. It has always access to the binary or the original program to interact with it and observe its outputs, and then it needs to rebuild it from scratch basically, and it is scored by looking at the original test case or by creating new test cases and then loading in the program from the model itself and seeing, all right, does that match exactly what we gave the model? And there are different approaches for this, but like that's the general approach. And the interesting thing is that if you try to push models harder and harder towards these directions, you observe the models trying to cheat your benchmark in some way, which is one of the most important things right now in benchmark building. So cheating means that the model comes up with some solution that you did not intend to do. So I, with some people at Epoch, build a benchmark which is just that is called MirrorCode. And it has access to the binary, but read only, so it cannot really look into the source code. And when I was brought in by Tom, who is the lead author, I told him, all right, I think the models are able to do these things. And I kicked off a run. And the first thing the model did was just copying and wrapping the binary into a Python script and calling it done. I was like, wait, that's not what I intended to do. So we built some things around that to circumvent these things, and then the model tried to probe the test cases and build a giant lookup table. So basically, every time you have some of the test inputs, the model would just replay the result that was expected, and that's also something we then circumvented by building new tests which the models weren't able to access, and then the model was not able to cheat this. But there are a lot of different other examples for all kinds of benchmarks where the model found some way around your initial setup to score perfectly or to score way better than the thing you intended. So a lot of modern benchmark design is trying to find all these ways and trying to circumvent these ways, which is often more work than creating the benchmark itself.
But how? So this.
No, you go. Sorry.
So like this is for verifier task, right? But what about like how you measure how good the slides are, right? Or like something that is more like human judge related.
Yeah, for this, one of the poster childs is, or there are two which are often used. One is called GDP-val by OpenAI, where the model has to do some kind of task and sometimes it has to create slides. And OpenAI also worked with experts in these domains, and the experts had to create slides themselves. So we have model-generated slides and human created slides, and then either an expert or more often these days another model is asked to compare the slides and pick the better one, which means for slides that sometimes the slides that just look better or are presented more pleasantly when even if their content might be slightly worse. And the other thing that we are also seeing a lot is what Apex Agent does. Apex Agents is basically the sweebench of Office task. The model is dropped into a bigger file system and has to sort through or go through the files to answer a question, and then has to create something, whether it's a report or some slide deck. And afterwards, it is created against a rubric, and a rubric is basically a big prompt with different things the model has to satisfy, and that rubric is then given to a model with a solution from the first model, and the model, so the judge model has then to tick off every box or say, all right, this is satisfied, this is not satisfied, to finally judge its output. You could also do these things with humans, but it is hard to scale these things and to run a lot of these benchmarks, especially if experts are involved, which are expensive to source or need time to work with. Using LLMs for these things is just the more scalable approach.
And do you need these expensive people mostly for just labeling data? Or like how are you using them?
Yeah, I think for those tasks is mostly either labeling data or creating the initial benchmarks. And it is becoming only more and more expensive. So for Apex agents and for other evaluations in this area, we know that the costs are low or mid 5 figures just for the creation of a benchmark, which is a lot, especially if you think that benchmarking is or was one of the prime things that academia was still able to create, because model training is way too expensive these days for academia. But those expert created benchmarks are now also out of question for the academic field to create, because they don't have the knowledge. That was different back in the MMLU days or in the GPQA days, where you could source some undergrad students and ask them to label all the data. But these days, because the questions are just so hard and need so much knowledge, it is out of question for this kind of benchmark to be created by academia.
Like, do you think there are like several concerns about the benchmark for like very long that are running, that are measuring like very long runs, right? And do you think like currently we can measure, I don't know, days or weeks of agents that are running?
Yeah, it's one of the hardest things right now is how we probably score them, and also when we might want to stop a run. Because if we still see some improvements after days, it's hard to say, all right, this is probably the best it can do, or if we run it longer, we might even get to the result. And it also is super expensive to run the models for such a long time. And in theory, you want to have a lot of runs to put a good number onto these things, because you want to increase or you want to decrease the variance by increasing the number of runs. But for these long horizon tasks and benchmarks, because they are so expensive to run once, the number of runs gets decreased a lot. So for benchmarking and for putting some reliable number onto these benchmarks, it is a really hard problem. And it's also a hard thing to train on, because you you don't want, if you are doing a reinforcement learning, you don't want every rollout to take days to then assign like a single reward on them. So that's, all these things are super hard questions with not the perfect answers yet. There are certain directions we can go, but yeah, it is an open problem.
So for the evals work that you're doing at Prime Intellect, what's been the most interesting, and what has been changing the most for you in the last few months?
So the most interesting thing is that we are working a lot right now on an overhaul of our framework, which is called verifiers, to build these evaluations. And the thing we realized is that it's super important these days to not only evaluate the model itself, but also the harness, so the scaffold or the CLI that the model is placed in, as these things are really tied together these days. So you want to evaluate not Claude, but Claude in Claude Code, or Claude in Cursor Agent, or Misuse Agent, and all these things, because the models are trained these days in these harnesses. So you need to evaluate them, and that means you need to rework a lot of things for this to work properly. And it also gives you a new set of interesting challenges, especially for evaluations where you want to control a lot of these things which you might not be able to control. For example, if we are thinking about, and going back to the web search related things, some of these harnesses don't allow you to block certain web results or to block certain domains, and that is a weird problem, because you need to block certain domains so the model is not able to find the answer immediately. But some, especially the closed harnesses or the harnesses by the model vendors, sometimes don't allow you to set and to block certain domains. It's kind of weird to find some solution around that.
So I've seen on artificial intelligence the idea that exactly what you're talking about, that the harness and the model need to be evaluated together. And they've done a cross harness comparison, and at least circa, I think it's Opus 4.6, they're showing open code ahead of Claude Code and Codex. Do you have any opinion on what the best harness is right now?
It is super, super weird. For some models, the harness from the model maker is the best. That is especially the case for the models from OpenAI, where Codex often is the best harness. For Claude, it seems like other harnesses might be better. And the reason for that is, or one of the possible reasons is that, like, the harnesses are products and they try to cater to a lot of different users with different use cases and experiences. So the usage might be different, whereas for some of the harnesses that are more catered towards developers and power users, try to push the model into one direction and to maximize the performance. So that might explain the mismatch. But yeah, it is really interesting, and it's also kind of weird to not know which combination is the best unless you run it.
Do you think like the future is like models that build their own harnesses, or we need to have this like constant, like kind of deterministic part of the models?
I think we will definitely go into this direction, and there is some initial work that is done right now, especially in the academic subspace, where the models or the harness co-evolves with the model by, for example, adding skills during the run to then learn, all right, if I do these things, it means that these things will happen. So you should probably just do a different thing, or by writing small scripts that the model is able to reuse, or maybe even installing things like tools. So this idea of evolving harnesses, and if you think about it, things like OpenClaw or Hermes Agent are also going into, or kind of going into this direction, and they are huge. Like, they have hundreds, if not millions, of users. So we need to evaluate also this kind of evolving harness, or this user space which continuously adds new knowledge and new skills and new things over a long horizon.
I'm really worried about the lack of Chinese open source like proprietary agent harness. Normally, I wouldn't want something to be proprietary at all, but actually you really do need, it seems, telemetry and tracking of long-running agentic coding traces. And while OpenCode does a little bit of telemetry and tracking in exchange for free access to the Chinese models, do you agree that this is a serious problem, that they don't have like a flywheel the way Claude Code and Codex are?
Yeah. I think not only for Chinese models, but in general, that is a huge problem. And also, it's the thing that more and more companies realize. So Zipu, which has released GLM, has now its own harness, which is called Z-Code, and DeepSeek is now searching for and building a team for a harness. And Kimi has Kimi Code now, because they all realize that the harness is an integral part. You also want to train in your harness. And if you don't own your harness, so if you train, for example, in Claude Code and they update it to a different version, which completely works differently, you have no control over it. And the last thing you want is someone else, maybe even a competitor, to control such an integral part of your experience.
And so how do you think the best eval will look like, let's say 5 years from now? Do you think we'll still keep coming up with new evaluation, or we'll reach the perfect one? And if so, how it will look like?
I don't think we will ever be able to find the perfect evaluation, because there are so many different things everyone cares about. Some people care a lot about writing, about a good and friendly user experience with a model, which not a lot of benchmarks exist. Others want to the model to build everything from start to finish, which is the coding related things. Then we have life sciences. So I don't think there will ever be one benchmark. And we are also finding new and interesting ways in different directions to test new capabilities. One of my favorite examples that I come up very often, which I'm surprised by how how long it was able to, or how late it was built, is a benchmark called post-train bench, where the setup is that the model that we are evaluating is placed inside its harness. So Claude is placed inside of Claude Code, and then is given a task to fine-tune or to train a model, for example, Quen or small LM, and is given the base model, and it needs to improve on an evaluation such as AMI 2026. And then it is it has access to one H100, and it just needs to train the model. And that setup is super, super simple. It has not a lot of different gotchas, has access to Hugging Face data sets, can do whatever, and there, and in the end, is a model which checks through the trace to find out whether it trained on the benchmark or cheated in some way. But that's the setup, and that was released, I think, a few months ago. And it's so simple. And now we are more and more going towards the direction, or into the area of, all right, we want to find out how to automate and how to benchmark some of our work, so the ML engineering and ML research work. And all these areas is completely new, and we will see even more innovations in this regard over the coming months and years. And once the models are as good in those things as they are right now for ML research, we might find some different ways to evaluate them.
So, but how does even not the optimal one, let's say that we have different field, how do you think is the best approach to actually measure progress, a real progress, even in specific domain?
I think we are moving more and more towards open-ended problems, and also we are moving more and more towards single runs, where maybe the final evaluation result and the thing that we measure is not one specific number, but a report from an agent which says, all right, it tackled this problem with these steps, and that is super interesting. Or that's also if kind of an evaluation, solving completely novel things, finding novel vulnerabilities and things like Firefox, solving new math problems. If you think about it, it's also kind of a benchmark. The sad thing about these things is that you can only solve them once. Of course, you can once you found out what the solution is, can try to replicate it, but it's less interesting to solve the math problem a second time or to find this vulnerability a second time if you know where to search or if you know how to find it.
So, we've talked a little bit about reward hacking. Do you think that that's just going to get worse as models get better?
Yeah, it will get even more crazier with things you could not even imagine. One of the most interesting ones I've seen lately is also coding related, where the people of Program Bench found out that their verification step was in a different sandbox, and that sandbox was web connected. And somehow the agent that was evaluated found out that the verification step has internet. So it wrote the code that fetches the binary. Then during the upload, during the verification step, it downloaded the binary to score perfectly. And like both things are so crazy that the agent is able to find these things out. And there are a lot of different things where as soon as you know them, it kind of seems obvious, but then the next version of models does things differently. By, for example, another somewhat related thing is that the models found out that or sometimes find out that you have different your block list works in one way, and if you try to get the URL by some weird string concatenation, you are able to circumvent the block list and are able to retrieve results that way. So somehow the agents are only getting more creative in those things, and for benchmark building, the more and more of the work is just finding all these weird things, and often you find them during the runs and then trying to circumvent.
So, and do you think like we can actually like train on these like benchmark? Like there is like a lot of discussion, between like environment and benchmarks and like to eval on the environment or like to train on it. Like, what are your thoughts about it?
Yeah,
Do you think like benchmarks like are good environment to train on?
Yeah, so there is no real differentiation from the technical sense between environments and evaluations. You build the same thing, exactly the same. And the one thing that is different is that like benchmarks these days are just the holdout set compared to classical ML, where everyone kind of agrees on to not train on the benchmark itself, to keep that one separate, but to train on everything else. And that's the area where everyone seems to agree on. But yeah, from a technical standpoint, there's no the exact same setup during training happen during your evaluation stuff.
But more like a higher level perspective, do you think that environments that are good for training are good for software evaluation and the other way around?
I would say so. In the best case, evaluations are probably a bit higher quality because you check them even more thoroughly to ensure that everything is solvable and that everything is reproducible. And in the best case, that's also how your training data looks like. But if you're being honest, that's not really the case. So the training data might be a bit more noisy, but in theory, there is no real difference.
And what do we do to handle different types of noise and subjectivity and verifiable rewards in an evals anyway?
Yeah. The hardest, or the thing I've realized working a lot with different people, is that everyone has some different opinion, and you need to find some common denominator. Some people say, all right, this prompt is somewhat ambiguous. Others say, oh no, this is completely fair and the model should do these things. There is no real rule for those things. You need to work with different people to find out which things are possible, which things are fair, and which things are too hard. And the thing you and I might agree on is something other people might disagree on. For example, For SweBench verified, we found during our analysis, that some of the tasks are probably not solvable by the information that is given to the model. And I had a lengthy discussion with someone else who said, no, in theory, everything should be possible because a human was able to create the initial solution. So it is solvable from a theoretical point of view. And I disagreed with him a lot, but I can also see his point of view why he thinks that.
So, do you think like we should go to tasks that are like superhuman, that it's like humans can't solve them?
I would say so, or we are definitely in those areas for some of the tasks. If we think about math discoveries, some of the solutions by some of the models are not done by humans. That's not to say that a human will never be able to come up with those things, but especially for these super hard tasks and for science in general, we might go more and more towards the direction that humans are able to verify the work and verify that it is correct once they see the solution. And we are also able to state the problems, right, for all these math-related questions. But maybe some of these solutions are too hard or too obnoxious for us to prove properly.
And what about pre-training? Do you think like we should have the same evaluation for pre-training, or like we need to come up with new one, or this is something like who cares about pre-training?
For pre-training, not a lot has changed, and we mostly still care about like the knowledge it picked up during a training. But we are moving more towards including some of the agentic traces during the pre-training mix. But on the other hand, you need a model which is trained to follow instructions. You need to have a model which has a long context to be placed in a CLI. So I don't think the pre-training knowledge stage or the evaluations for the pre-training stage will change a lot, because all the interesting capabilities are in later stages of the training.
Well, one thing that I think comes from pre-training is models' knowledge in a temporal sense. So like Sonnet is supposed to be coming out, I think, today or something, and they're saying a data knowledge cutoff date of January of 2026. That's the first model that knows anything about 2026 without ragging off the internet, right? So isn't that kind of important?
It is. But also you could find those things during a mid-training stage as well, if you want to. But yeah, I would say all these knowledge-related things are pre-training evaluation things, and they are still important because you don't, or for some of the questions or for some of the things you do, you don't want the model to first consult the internet, or the model does not even consult the web because it's so sure in its knowledge that it does not even need to search in the first place.
And what do you think like the future direction should look like? You know, like we can come up like with more like testing tasks that are more like real life tasks, right? That like, I don't know, like how much like you can end like full end-to-end real work, but it's much harder to evaluate versus very clean, that you have very verifiable measures. I don't know, like something that it's very like something related to coding or something like that. Again, versus it can be economic values. It can be like the amount of money that I bring to the company or whatever. Do you think it's possible to do it? Do you think it's worth to do it?
I think we still need to have both things. For us who look into those evaluations, we care about very specific things to know how it stacks up in these things. To be more concrete, we want to know how good a model is at tool calling, so we know, all right, the model, if we place it in a CLI, it will at least work. And the benchmark just for tool calling is called tau bench, and It just tests how well a model is able to call different tools and interact with the user. That in itself is not a valuable economic task, but it's it is a prerequisite for a lot of these things. So a model that is good on TauBench can be used in the different harnesses. But I think the things a lot of people are more interested in are those economic tasks that mimic our real use cases and mimic our real life. Unless you both disagree, what are you looking in when a new model is released? What are the benchmarks you care about?
So I don't know. I feel that like there are a lot of times, there are models that they are okay, or there are some like this like feeling or like this sense that you work with a model, right? And it's very good. Like that it's very good, and it doesn't matter like how much like it score on like this benchmark or this benchmark. Because like maybe we can talk about like now about like Chinese models, right? Like for a long time people say like, look, they are like good on this benchmark, right? But like what you want. But you had this feeling that like, no, we can't actually work with this model for agentic task, right? And now, for example, like people said for the new GLM, right? GLM 5.2, that like maybe this is the first model that actually we can work with it and like we can make this like a agentic task, right? Even though it's not like a huge improvement over all the benchmark, but that's still fine because we have this feeling that like it's a good model. Do you think we actually can measure this like feeling?
I think so, yeah. And I think at least for if we look at GLM 5.2, which is an amazing model, it's very fun to use and it just works, which is super interesting. But you see like the initial benchmarks from the model maker itself and then independent benchmarks from third parties. And the thing you see some of the times that kind of puts a number at those feelings is that it is really good at a few benchmarks, but as soon as you go into other directions or change the things, it just places really, really badly. And that's what the community refers to as benchmaxing. Like the model makers just try to get high numbers on some benchmarks, and the real life is more messy, and that's why it didn't feel so good. But GLM 5.2 is just good on every benchmark the people threw at it with very few exceptions. And that's why it rightfully is having the success it has. And I think we will see this more and more as now the open source ecosystem, especially in China, is going more and more into the breadth, where they train on more and more in different environments, which then gives it more utility to be actually usable in other use cases. Before GLM 5.2, you are still able, or you were able to use these open models, but you had to change your usage a bit by prompting it really, really well, by especially long context was bad. So when I used GLM 4.7 for a while as my main model, because I wanted to know, right, is it really that good, or do I want to use the latest GPT model? And it was really usable, but you had to do a lot of settings. For example, you had to kill the context way earlier than the context window. Killed it, I think, at 30%. Versus the full range. I prompted it more specifically, but then you were able to use it, and the model itself was good. But like GLM 5.2 is the first agentic model which is really well rounded in both areas.
So, do you in your experience witness sampling behavior or having any impact on your evals, or do you even look for that?
Yeah. Sampling is one of these things where people either set no values or some random values, and then just run with it. I found some, or especially because I think open models are super important, and they always, or a lot of them, specify the different sampling parameters they run for evaluations. And if you just set random values or like the default value of temperature of 1, some of the models perform worse. And the thing I really want to do is to find out how worse if I run it over a large sample size. Because the bad thing for those things, if you want to have a statistically significant number, we are not talking about 1 or 2 runs, we are talking about tens or maybe towards hundreds of runs to find out how big of an impact sampling parameters are. But it definitely has some impact. And that's also why open models are harder to use, because you need to set those things. Whereas you can't set the temperature for a GPT model. So that's just not possible. So you can't really fuck it up.
Well, I point out that we were able to, and that the most recent models have had that completely taken out. And, it was a slow boiling pot for removal of all, sampling parameters. But yes. Okay, fascinating.
But the most important question, do you use MinP?
MinP support really depends on how you use and what you use. And that is even weirder, or the more esoteric setups are even less supported by some of the frameworks. So I don't use it.
You don't have to answer. That's fine. But like you talked about sampling like different or many answers. So like when you try to evaluate a model, how much you actually like try to make it like rigorous statistics analysis, right? Because like we all know that like machine learning papers and works are really bad in statistics and analyze. Like the best case that you will have, some error bars that it doesn't clear even like what they actually mean, and like what are these like they average over these like the different iterations. So what is your take? Do you think it's important, or do you think like it may be that it's like not important, and like maybe it's like even if it's very noisy, like the direction of the over different models, different tasks, whatever, it's good enough?
Yeah, I come from academia, so I think it is important, but I acknowledge that it is just very expensive, and especially if you want significant numbers, it is prohibitively expensive, especially for closed models. If you look at the runs and the cost of runs that are now not 4 figures, but are even going into the 5-figure range for one benchmark, it's not really a good thing, or it's not really realistic to ask for tens of runs for just one headline number. So it is really weird, and I want to find out how important those things are, like the sampling parameters. But yeah, I would like to do more runs, or I think everyone would probably like to do more runs, but are handicapped by some kind of resource. Either it's time, or it's money, or it's both. And that's a weird thing. Being honest, we are doing all these benchmarks, but in worst case, they have such a high variance that maybe some differences aren't that big that when people realize.
Seems like GPU availability is a problem too. I guess it's connected to price, but for some people, they can't get GPUs at any price. I guess notably in China, right? Depending on the GPU, and similarly depending on the model, right? So what do you think about these like further regulations, export controls, and related?
I think those things are probably out of my area of expertise, especially as a European.
That's fair.
And so I have a question. So like, why do you think it looks that like at the end the frontier models are quite like close in their capabilities, right? That like it can be that like sometimes, right, like GPT will be better, and sometimes like something else, but like they are quite close, and like there is no like a huge gap for each one of them. And even when you talk with frontier models, they are quite the same, right? Like maybe they have like different style, but in their capability they're quite the same. Why do you think is this the case? Is it because people are moving across companies? This is because of the data, or like the way there is something like fundamental that we are doing there?
I'm not necessarily sure whether I'd agree with those things to begin with. I think there are some nuances and there's some differences that make some models, at least for some time, better than the others. if we are talking about benchmarks, like Mythos was better by a long shot during its announcement phase. It was not really released. Fable the same. But like for some time, Claude was better at coding related stuff when people mostly switch towards codecs. Others still are happy with Claude. But I think like if you push the models to their maximum performance, you still find some differences between them. And if I have to think about why they might be close, it's data related things, it's compute related things. If all the labs have similar-ish compute, they are able to train similarly capable models. But then again, it is rumored that Mythos is such a bigger model compared to the others, but this might give Anthropic an edge over the rumored smaller GPT model for some time if they're continuing to cross-train it.
I claim that there's serious differences mostly today related to alignment and safety, right? So, for example, you've got Anthropic taking the most restrictive approach possible, straight up banning anything involving biology with Mythos, even before any regulations forced them to, and having the highest refusals. OpenAI being very close, but being just a little bit more permissive. And then, you've got Grok being very politically right-wing and being probably the only model that can really articulate ideas like that while still maintaining some modicum of safety and alignment, at least after outcry, right? And then you've got open source models, right? And then maybe even uncensored variants of those, which are just completely unhinged. So I claim that there is differentiation in terms of de facto like model outputs, even if at the very top of the capability. I agree, Ravid. I can barely tell the difference between GPT 5.5 and Opus 4.8 in terms of which is smarter, but I can tell in terms of which one is going to be more permissive to run certain queries, right?
Yeah, I agree, but okay, maybe from will answer, but like I just want to say that like I agree that like yeah, of course that like if you like train very specific thing that like bans on like very specific like kind of topics or questions, so you will have a different, right? But in general, like it's quite surprising that they are very similar, right? Because think about it, like you have different people, different algorithms, different data, like everything is different.
Well, scale AI, right? For post-training data, not that different.
With regards to the safety aspect, I think, or I recently looked into those things because I was interested in how safe open source models are versus closed source models and what people actually use for misuse. And the surprising thing I found out is that aside from image generation, where open source models are misused for really nefarious things, closed models, at least in the text domain, are more used for misuse, are more prevalent. And the people that misuse them, for example, for hacking, just use the API or the models themselves, then jailbreak them to circumvent the safety measures. And once they are able or were able to jailbreak them, the models were just going completely wild. So at least right now, it does not seem like people are interested in open source models for these use cases, as it's way easier and still continues to be easy to jailbreak a closed model versus finding a ton of GPUs, training a model to obliterate all its safety measures, then setting up the inference for that model to then use it for or to misuse it. So at least the current state of the world, and that has been the case for quite some time, is that closed models, because they are way easier to use, are also more widely used for nefarious purposes.
Do you think like closed models are becoming like better in detecting this misuse?
Yeah,
and preventing?
I think they are. but they are not covered. Like they aren't, and they probably will never be able to be 100% secure against jailbreaks or misuse, which is then or is an open question. But I would push back on open models being so much more unsafe because in theory you can circumvent these safety measures by post-training it. Post-training is not easy. You need a lot of experience. You need a lot of GPUs, and when you can just prompt, but that also applies to open models, which are way easier to prompt inject. That's let's not pretend they aren't. But like the most misuse, at least right now, from the things we know publicly, is just jailbreaking models.
Okay, I think we're out of time. Do you have anything else that you want to add?
Maybe the last things, because we are talking about open models, I think it is really interesting to see how open models are continuing to be close to a frontier. And every time someone is saying, all right, this is the final model, and that happened time and time again. That's the final closed model release that's so far ahead from all the others that open source is never able to catch up. Some model release few weeks or months later was able to catch up. So it is interesting and definitely something to look out for, our open models and them continuing to stay close to a frontier. And I think that's a really good thing for the overall ecosystem, that not single company is so much ahead that all the progress is gate-kept by one or two entities.
Do you think it will stay like that? Do you think like the gap will stay similar? Or do you think like all these like talks about self-improvement? Do you think like if Anthropic will figure it out, like we understand like how to do the very fast self-improvement, do you think like the gap will change and they will just like reach to AGI really fast?
I think the gap will stay the same, or maybe even continue to shrink. Because all the open model makers are also building those things and finding similar-ish results. So I don't think that anyone will be able to pull ahead by so much that they are unable to be caught up.
It seems like Anthropic is really hoping that they pull ahead. I mean, do you think then that all their safety stuff is for nothing?
No, I think their safety stuff, especially for them, is honest by them, and they are really concerned about these things. But I don't think that a single company is able to find something that will put them so much ahead for basically forever that no one is able to catch up any.
Okay, Florian, thank you so much for joining us. It was a real pleasure. And
Thank you for having me.
And thank you for the audience. Thank you. Bye-bye.